Hello there, the Math Dog here. In this video I'm going to look at graphing rational functions. This is going to be part one of a series of videos I'm going to make on rational functions, which we'll right now just call fractional functions. These are functions that can be written as fractions. So we'll be looking at some of the behavior of these functions and how to sketch them without a calculator, and then we'll use a calculator a Desmos graphing calculator to verify our results. So let's get started here. Right, so I'm going to start with what I call the big little concept, where I'm keeping my numerator fixed and I'm shrinking the size of my denominator to make it smaller and smaller. So 1 divided by 0.1, remember, means 1 over 1/10, and when you divide fractions you multiply by the reciprocal. So this is equivalent to, first of all, 1 divided by 1/10, which is equal to 1 times 10 over 1, which is 10. And I'm not going to keep repeating this process here, so this is 1 over 1/100th, which will equal 100. So notice as I keep my numerator fixed and shrink my denominator, these numbers are going to get larger and larger. This would be 1 over 1/1000, which is going to be 1000. 1 over, this is going to be 1 over 0.001, which is 1 over 1 over 10,000, which is 10,000. So we could, just keep going and going and going. 1 over 1/1 trillionth would be 1 trillion, etc. So same thing applies when I take, say, 1 divided by negative 0.1, which should be 1 over negative 1/10th, which is going to be negative 10. 1 over negative 0.01 would be 1 over negative 1/100th, which is negative 100, etc. So it's going to keep fix the numerator, make the denominator get closer and closer to 0. The number in the bottom is getting smaller and smaller. Well, the result is this is going to be getting a bigger and bigger and bigger negative number. So what we just showed above is, so if I have the function f of x equals 1 over x, as x comes to 0 from the right side, so here's my xy axis. This is the line y equals 0. This is the line x equals 0. This is the y-axis. This is the x-axis. So as x comes to 0 from the right side, so this is what I mean, 0 plus. It's coming to 0 here. This is x equals 0 from the right. The function is actually shooting up to positive infinity because it's growing without bound. It's going up this way. Now as x comes to 0 from the left, so it's coming closer and closer to 0, which is what I was doing over here, because the numbers are getting smaller and smaller, which they're approaching 0. This function is going to shoot down to negative infinity. So that's why we get this behavior, and we'll talk more about this shortly. So now we could flip this around. We have the little big concept where I fix the numerator now, though I blow up the denominator. So 1/10 is 0.1, 1/100th is 0.01, 1/1000 is 0.001, etc. 1 over, you could go 1 over a trillion, 1 over a zillion, etc. But you're getting smaller and smaller numbers, so it's going to 0. Okay, so things are going to 0 here. They're not getting there, never actually going to quite get there, but they're getting closer and closer. Same thing, 1 over negative 10 is negative 0.1, 1 over negative 100 is negative 0.01, 1 over negative 1000 is negative 0.001, etc. So again, they're negative numbers, but they're getting closer and closer to 0. So now, if we have the function f of x equals 1 over x and we blow up x to infinity, so here again, this is the line y equals 0, this is the line x equals 0, this is the x-axis, this is the y-axis. As x goes to positive infinity, this function is going to start hugging this line y equals 0 here because it's getting closer and closer to 0. So as I blow up x to infinity going this way, f of x will approach 0. Same thing the other way. So now if I'm blowing up x to negative infinity, the function is going to get closer and closer to this line y equals 0. So as x goes to negative infinity, f of x goes to 0. So let's continue now. Let's actually sketch the rational function f of x equals 1 over x. So based on my discussion just in the last couple minutes, as x comes to, well, first of all, before we do that, let's fill this table out. So we have 1 over x. So if x is -1, that's going to be 1 divided by -1, which is -1. So that's the point 1, -1 on, -1, -1 on our graph. If x is 1, 1 divided by 1 is 1, so that's point 1, 1 on our graph. So let's plot those points. So we have -1, -1. We have 1, 1. Okay, and I'm going to highlight the x and y axes here. Like so. Now, again, this is the x-axis. This is the line y equals 0. That's the x-axis. This is the line x equals 0. This is the y-axis. So we know these 2 points are on the graph. So as x approaches 0 from the left, coming in this way, and it's going to be down here, it's going to shoot to -infinity. So what's happening is the graph is coming through here. Let's do it in red. The graph's coming through here and shooting down. It's going to get closer and closer to the line x equals 0. Okay, so now as x approaches 0 from the right, which is this way, the graph is going to come like this. It's going to shoot up to +infinity. Okay, so now as x goes to +infinity, which is out here, the function, as we showed, is going to get, so this is going to be, as x approaches 0 from the right, we said this is going to be +infinity, so let's fill this chart out here. Now as x goes again to +infinity, which is this way, this function is going to hug this line y equals 0. It's never quite going to get there, so f of x we showed is going to go to 0. So the graph is going to look like this. Okay, and then as x goes to -infinity this way, the graph is also going to hug that line y equals 0 like this. So we get this, what's called a hyperbola graph. Let's spell that again. Let's use a different color. It's easier to read. So that's a hyperbola. Now you notice it gets closer and closer to this line x equals 0. It never gets there. And it gets closer and closer to this line y equals 0. It never gets there. These are called asymptotes. This is a, right here, this is a horizontal. Let's not use green. This is a horizontal asymptote. That's didn't spell that right. And this is and that's the line y equals 0. And let's use a different color there. So this y-axis is a vertical asymptote. And this has the equation x equals 0. So it didn't fill it out here, so this should say 0 here, because as x goes to infinity, the function approaches 0, but it never gets there. Alright, so let's continue this idea. We're going to go into even more detail on this, and then we'll do some other examples after this next one. So now let's go a little more detail. This is a little bit redundant, but I'm going to do it again. So suppose again I have the function f of x equals 1 over x. So let's find all horizontal asymptotes. We just did that. That's y equals 0. Okay, because as x goes to +infinity, we showed already that f of x is going to go to 0. So we also, let's plot what we know. We've already done this, so we know that the function goes through these 2 points. So as x, and let's draw in our let's highlight our axes again. So again, just a reminder, this seems to give students some trouble understanding the x-axis actually is the line y equals 0, and the x-axis, the y-axis actually the line x equals 0, the vertical line x equals 0. So again, we know the general form of the sketch. As x goes to positive infinity, the function is going to hug this horizontal asymptote y equals 0. So our horizontal asymptote is y equals 0. Again, because also as I go to negative infinity, as x goes to negative infinity, f of x goes to 0 again, but it's coming from underneath this time. So it's going to come like this. Okay, then vertical asymptotes, well, we showed that's going to be x equals 0, because as x goes to 0 from, say, the left, f of x goes to negative infinity. So it's going to go like this. Okay, and then as x goes to 0 from the right, which is this way, coming from the right, that's what the plus means here. This means 0 from the left, this means 0 from the right. F of x goes to positive infinity. So it shoots up. It's closer and closer to that line x equals 0, but never quite gets there. Okay, so now there are no holes. We'll talk about those in another video. There are no slant asymptotes here. So now x and y intercepts, if there are any. So an x-intercept is where the graph crosses the x-axis, which is the line y equals 0. So to solve for that, you set the function equal to 0. So for an x-intercept, called xint, you set the function 1 over x equal to 0. Well, if you cross multiply here, you get 1 equals 0. So that's not true, so that's false. So there is no x-intercept. And you can see that the graph's never going to cross the x-axis. So then the y-intercept is where the graph crosses this line x equals 0. Well, that's where the function has a value 0. So the y-intercept, you always set the function equal to 0, which is going to be 1 over 0, which does not exist because that's division by 0. And so there is no y-intercept either. You can see that it never crosses that line, so there is no point of intersection there. Alright, so we did that. They do not exist. Now finally, the domain and range. D, I'll use interval notation. So as I go from left to right, the function exists until 0. It breaks there due to that vertical asymptote. So domain is going to be negative infinity to 0. I put a parentheses because it does not include 0. Union, then it doesn't start up at 0, it starts up immediately after 0, so that's again a parentheses, not a bracket, and that goes to 0 to infinity. The range, I start down here and go up, so it's good until here at 0 there's a break again, so it's going to be, the range is going to be negative infinity to 0, then immediately after 0 it starts up again, so it's going to be union 0 to positive infinity. I could put a positive there if I like. Okay, so that's an analysis with pencil and paper, so to speak, of the function f of x equals 1 over x. So now let's take the function f of x equals 1 over x squared. So this time notice that the denominator is always going to be positive. So we could again make a little table here. So if x is 1, 1 squared is 1, so f of x is 1. If x is negative 1 this time, no, negative 1 y squared is 1, so you have the points 1, 1, and negative 1, 1. So it's going to be different than the previous function. So we have points here and here. Okay, now let's talk about horizontal asymptotes. So notice here as x goes to positive infinity, this denominator is going to grow huge. So f of x is going to go to 0. So it's going to come like this. Again, let's highlight those x and y axes. Again, let's write the equations of those things also. So this is the line y equals 0, the horizontal axis, which is the x-axis. And this is going to be x equals 0, which is the y-axis. This thing's going to get, again, closer and closer to 0 here. It's never quite going to get there. And then going, as x goes to negative infinity, that's going to be a huge number squared, but it's going to be positive, so this is going to be getting closer and closer to 0, but it's never going to quite get there. So we have this so far, okay? So the horizontal asymptote is y equals 0. Vertical asymptote, so this should be f of x goes to 0. As x approaches 0 from the left, which is this way, that's going to be 1 over a tiny negative squared, but a tiny negative squared is a positive, but it's going to be 1 over a tiny number, and we know this is going to grow huge, so it's going to go like that. Okay, it's never quite going to get to this line x equals 0, but it's going to keep getting closer and closer to it. So f of x is going to go to positive infinity this time. Then as x approaches 0 from the right, that's going to be 1 over a tiny positive squared, which is a tiny positive, so this thing's going to go like this, and you're going to get a graph that looks like this. This should be goes to positive infinity. Okay, so again, vertical asymptote again is going to be x equals 0. Any holes? There are no holes. We're not doing problems with holes yet. We will in a later video. No slant asymptotes. So x and y intercepts. Well, visually you can actually see, again, there are going to be none, but let's again show the process. So the x-intercept is where the graph would cross the x-axis, which is the line y equals 0. So you set the function equal to 0. Again, you cross multiply, you get 0 equals 1. So it does not exist. Okay, the y-intercept is where the graph crosses the y-axis, so you set the function equal to 0. In other words, you take f as 0. F of 0 is 1 over 0 squared, which does not exist because that would be division by 0. Okay, so these do not exist in this particular problem. The domain and range, well, you can see the domain again. If I come this way, it's negative infinity, but it breaks at 0. So there's a discontinuity there, then it goes to positive infinity. So the domain and range is going to be negative infinity to 0, union 0 to positive infinity. The domain now, this time, the range this time is different, so it doesn't start till 0. So it doesn't include 0, so the range is going to be 0 to positive infinity. There are no negative values for this function. Okay? So that covers that function. Let's do another one. F of x equals 2 over x plus 4. So this follows what happens with all functions. So I did have a video on horizontal translations. So this is 2 over x plus 4. So this 2 is going to, well, let's talk about the bottom first. So this is going to be a shift of the parent function 1 over x 4 units to the left. You think it might be to the right, but it's not. And we talk about that in my horizontal translation video, the reason why that is. But this is a shift 4 left. And then this 2 is a vertical stretch times 2, or sometimes called a dilation. So it's going to stretch it this way. Okay, so because really you look at it, this is 2 times 1 over x plus 4. Just like slope, a line of, if you have y equals 1 over x on a linear function, y equals 2x is going to be steeper. Well, that's the same thing here. This graph is going to rise faster than just 1 over x plus 4. So if you made a table, x here, and we're going to look at the parent function. We're not looking at this function. We're going to just use a shift. But if I have, this is going to be 1 over x, or f of x is 1 over x. This would be, again, negative 1, 1. So 2f of x, which is analogous to this, would be 2. And if x is 1, that would, f of x would be 1, and 2f of x, this should be actually negative 1, negative 1. That should be negative 2. If x is 1, then 1 over 1 is 1, and then in this case we're doubling it with that 2. This would be 2. So you have the points negative 1, negative 2, and 1, 2. But what I'm going to do is I'm going to draw the shifted function first. So I'm shifting my graph 4 to the left, and I'm going to draw in a vertical asymptote there. Like so, and I'm still going to draw in my x and y axes. So there's my original axes. That's my original origin, 0, 0, but what effectively I'm doing is I'm moving my origin to over here now. That's how I'm going to do this analysis for part of this at least. So my parent function was 1, 1 over here. Just treat it again. Instead of graphing here, I'm graphing over here. So there's 1, 1, there's 1, negative 1. Okay. Well, the original function goes something like this. That's 1 over x. But the new function is everything's stretched by 2, so it's going to, instead of going 1, 1, it's going to be 1, 2. It's going to be here, and instead of negative 1, negative 1, it's going to be negative 1, negative 2. So this function is going to rise faster. It's going to look something like this. It's going to rise faster than the original function. It's going to go like this. So this is, the green is this function here. Alright, so let's look at this. So you can see, hopefully, that the horizontal asymptote is still going to be 0. But the vertical asymptote is going to be here at x equals negative 4. Okay. There are no holes yet, again. No slant asymptotes. So x and y intercepts. This time, again, there's going to be no x-intercept, and let's prove that again. So we set the function equal to 0. Cross multiply, you get 2 equals 0. That does not exist. That's not true. Now the y-intercept, this time there actually is 1. So again, we evaluate the function at 0. F of 0 this time is 2 over 0 plus 4, which is 2/4, which is a half. So right here you can see there is your y-intercept, which would have coordinates 0, 1/2. Okay? So finally, domain and range. Okay, well the domain is negative infinity, and then it breaks at negative 4 this time. So it's going to be negative infinity to negative 4, not including negative 4, union. Then it starts again at right after negative 4, so it's negative 4 to infinity. The range is going to be negative infinity because you're coming up here, and then it breaks at 0. So the range is going to be negative infinity to 0, union 0 to positive infinity. Okay? So that's an analysis of that function. So let's actually, now we're going to go show this on the Desmos graphing calculator, which is a pretty nice online, it's an incredible online calculator. I won't just say it's nice. So let me open up Desmos, and we're going to show this last problem. So let's start with that parent function, y equals 1 over x, or you call it f of x, equals 1 divided by x. Okay, there it is. So now I'm going to move it. I'm going to call this g of x. I'm going to move that function, shift it 4 left. So that's going to be 1 over x plus 4. I didn't get that right. Let's try that again. It's plus 4. And there you see it's shifted 4 units to the left. There's your vertical asymptote at negative 4. And then h of x, I'm going to put that stretch in there. So that's going to be 2 divided by quantity x plus 4. There you see that the function, the green function, has twice the value. So here is going to be the point -1. Here's the point over here. So this is, again, if I treat this as the new origin 0, 0, this would be like -1, -1, and this would be -1, -2, etc. This would be from here, this would be 1, 1, and this would be 1, 2. So you can see the green function has twice the height that the blue function did. And this concludes the video, although I do want to check one other thing here. I just want to make sure. Come back to my graph. I did it, so it is x equals -4. I was worried I put x equals 4 there, so we're good. So this concludes the video. I hope it was informative and you liked it. Please give it a thumbs up and consider subscribing to my YouTube channel, The Math Dog, and you can put any comments in there. Also, if you like, you may share the content of this video with others. Thank you and have a good day.